In this video, I want to show you some formulas that we use for special products of binomials. Okay, so we have three formulas here, and it looks like in the first one it's a plus b times a minus b, which means the terms that we're using, the a's and the b's, are identical, but the sign in the middle is opposite. One's positive and one's negative. And the other two, we have a and b, but we're squaring it, so we're adding it and we're squaring it and then subtracting it and squaring it. And we have these nice formulas that we can use. Honestly, you can go ahead when you're squaring them, just put them side by side and multiply them out if you like. But once you get to using this formula, I think it'll be a lot faster and easier for you. Okay, so let's look at an example of what this first formula might look like. So if we have something like 3x squared plus 7 times 3x squared minus 7, okay, well, it looks like this 3x squared is in both places, so here and here. So this kind of is our a value. And this 7 then we have here and here. It's kind of a b value. One of these binomials is adding, and one of these binomials is subtracting. So we can use the formula and we can just say, well, it's a squared minus b squared. So we'll square the a term. So basically, we're going to take 3x squared and we're going to square it. So this squared will kind of come down to both of these terms. 3 squared is 9, and x squared squared, this power of a power we multiply, so x to the 4th. Okay, well, how about the b squared? Right, the b squared is going to be 7 squared, and that's pretty easy. That's 49. And our formula says what we're going to do is we're going to subtract those two squares. So it'll be 9x to the 4th minus 49. And that will be that product. Let's just go ahead and show you that it works out. If you were to use the series of distributions and just multiply it long, then you would get the same thing. And I'll show you why this is so nice. Because when you distribute through like this and then like this, we have the 9x to the 4th minus 21x squared plus 21x squared minus 49. Okay, well, what's so nice about that? These middle terms are like terms, and in fact, they cancel each other out. And you'll see that will always happen when you have the a plus b times the a minus b. So then you're left with that product that we had previously. Okay, and we actually call this the difference of squares because it's subtraction, which means the difference, and we have two perfect squares. So here's this second formula and an example. So we have a plus b, and that quantity, or this binomial, is being squared. So we're going to say this 2x is my a value, and this 5 is my b value. So we can just plug it right into this formula, and I'll show you why this works and why it's nice also. So a squared. So I'm going to take this a, which is 2x, and I'm going to square it. So 2x times 2x will be 4x squared. And then it's plus 2ab. So it's twice the product of the two terms. So 2x times 5 is 10x, but I'm taking double that, so 20x. And then b squared, 5 times 5 is 25. Okay, so here's that product. Let's go ahead and do it out long way and show you kind of why it works this way. So when I square something, that means I'm going to multiply it by itself. So I'm going to put them side by side and multiply it out. So once again, this series of distributions. So 2x times 2x is 4x squared. And then we'll have this plus 10x plus 10x plus 25. Okay, so honestly here we have our 4x squareds that are the same here. And we have our plus 25 that's the same here. The big difference is here we were able to go right to a plus 20x, and here we'd need to see that these middle two terms are like terms and we can combine them. So plus 10 and plus 10, that makes our plus 20x. Okay, so that's why this formula works, is because it's just a generalization of squaring this binomial using this distribution process. And the final formula we're going to look at is this perfect square of a binomial, but it's subtraction, so a minus b. So you'll notice that affects the formula here because this sign will end up being a negative. And in our example, it looks like our a value is going to be our 3x and our b value is going to be our 5y. We don't need to say that b is negative 5y because the negative here is included in the formula itself. Okay, so we are going to square that first term. So 3x quantity squared will give us 9x squared. And now we're going to subtract twice the product of the two terms. So let's multiply these together. So 3 times 5 is 15, and then xy. And then, of course, double that. Double 15 is 30, so minus 30xy. And then it'll be plus the square of the second term. So this 5y squared. So 5 squared and y squared. So 25y squared. And this will be what that product looks like using the formula. And of course, once again, let's go ahead and put them side by side and square this out. And I'll just show you long ways why this works. So our distribution here will look like this. 3x times 3x, and that gives us our 9x squared. And this gives us negative 15xy, another negative 15xy, and the last's a positive 25y squared. So of course there's two of these terms in the middle, and they're like terms, and they're identical, negative 15, negative 15. Hence where this 2 comes from, is because we have two of them. So when we add them up, you'll see we have the same thing. Okay, so there are just 3 quick formulas that you can use with binomials to maybe make multiplication a little easier or a little quicker.